All right, Ethan, let's read number 1. Let f be. Today?
Let f be a function that is even and continuous on a closed interval 0 to 3. The function f and its derivatives have the properties indicated in the table below.
So we know it is continuous on a closed interval. So just by looking at this, we're going to write out, or not write out, with the highlighter, put on top of f prime and f double prime the features of the original graph. So on here, we know if f prime is negative or positive, so here's f prime is negative or positive, my original graph is going up or down. So let's go to it, and I'm going to write on here, when f prime is negative, the graph is going down. When f prime is positive, the graph is going up. And then while we're at it, let's go to our double prime. When f double prime is positive, it's concave what? Up. When it's negative, it's concave down. So I have positive, so concave up, negative, concave down, and I have concave down. And I'm only doing this because I'm thinking ahead. So on part A, let's see, Dylan, go ahead and read part A.
Every point at which f obtains an absolute maximum value or an absolute minimum value. For each x coordinate given, see whether f contains an absolute maximum or an absolute minimum.
To find the absolute minimum and maximum of anything, we need to see the graph, right? So what's going to happen in the end, from B all the way to F, we're going to end up making a graph on the bottom. So let's save A until the very end. Do last. It'll make more sense that way. Otherwise, you have to think too hard. So let's analyze what we have. So if x is 1 and f of x is 0, we know that is a point at 1, 0. And then to the far left, if x is 0 and f of x is 1, that is a point on the graph, 0, 1. Is there another point on the graph that's given to us?
Yes.
Which one?
2, -1.
2, -1. So let's go ahead and graph those pieces on the bottom. So let's go to 0, 1. 0, 1 is right here. And then we have 1, 0. Then 2, -1. So we know these three are points, and what's going to happen in between the graph, we're going to worry about as we answer them. So let's go on to part B. Castro, read part B.
Over what intervals is the graph of f increasing? Justify your answer.
All right, so we know f is increasing by the following. The original graph is increasing when f prime is what? Positive. We're going to go ahead and find where f prime is positive. It is increasing at this interval. So let's write at 2, 3. And when you're justifying, I want you to go ahead and tell me what it is by what. So it is 2, 3 because f prime is what sign? F prime is positive. Now let's go to part C. Emily, go ahead and read that part C.
Over what interval is the graph of f decreasing? Justify your answer.
All right, so what interval is it decreasing? And it's decreasing when f prime has what sign? Negative. How many do we have?
2.
2. So we want to list them both with a union. So first one is 0 to 1, union. Then I have 1 to 2. And the reasoning is our justifying, because what is doing what? F prime is negative. And then let's go to our part D. On part D, Mason, go ahead and read.
Over what intervals is the graph of f concave downward? Justify your answer.
So concave downward. Is concave downward has to do with the first derivative or the second derivative? Second one. We've dealt with that earlier this week. So let's write out on here. On my second derivative, we know it is concaving downward at how many locations? On 2. So let's write on here 1 to 2, union, 2 to 3. And on your because, we have to go ahead and write the because with a double prime. Because f double prime is doing what?
Negative.
Is negative. And I heard someone call my name. Okay? All right. And then part E. Ryan, let's read that piece.
Over what intervals is the graph of f concave upward? Justify your answer.
So concave upward, we've already analyzed. It's when it's positive. And we only have it in one interval. So we have, is that 0 to 1? And that is because f double prime is what? Positive. And our last piece before we graph the rest and find the absolute minimum and maximum. Colin, read the last piece on F.
Find the x-coordinate of each point of inflection in the graph of F.
All right. Point of inflection happens when the concavity changes. So looking at this, is there a point of inflection if I have concave down and concave down?
No, but
That's not changing. But look at these two. Do I have point of inflection here?
yes,
At what number?
1.
At 1. So let's write x equals 1. And that's going to be because f double prime changes sign. If you want to even be specific and say f double prime is going from positive to negative or negative to positive, that's even better. But this will be acceptable. All right, is everyone good with this? Now let's go ahead and graph everything about what we have. When you're graphing concave up and down and increasing and decreasing, the best thing for you to think of is the following. Think of a circle. Let's all make a circle. And when I take my circle and divide it into its quadrants, so put a dot. And then at this point, I'm going to kind of exaggerate it. Let's start by exaggerating the top left corner. Here's that top left. Top right is something like this. Make it as big as you want. Bottom left is something like this. Bottom right is something like this. So I'm going to elaborate what is happening. Isn't this concave down right here? But from left to right, is it increasing? Now look at the right. Isn't that also concave down? From left to right, it is decreasing. Go into the bottom left. This is concave up. And from the bottom to the left, it is decreasing, and so on. So with that said, go to our first one. It says between 0 to 1, it is going down and it's concave up. So which one is it going to be? 1, 2, 3, or 4? 3. So here's my 3. So I'm going to mimic that, connecting from 1 or 0 to 1. And if you want to exaggerate it, that's okay. Make it very curved. That's completely up to you. So now let's go to our next interval. On our next interval at 1 or 2, it's got to go down and concave down. So is it 1, 2, 3, or 4? 2. So again, exaggerate it however you want. Oh, God. That's pretty good. And then at this point, the way we end the final one really doesn't matter because of the following. Not only should we go up, we are going to cave down. So which one are we looking at? 1, 2, 3, or 4? 1. It is 1. So as long as I'm going up, how far up doesn't really matter. I'm comfortable stopping right here. If you want to stop further up, that's okay. Just don't go too high and too low from these 2 points, because then you're just making up your own thing. So at this point, let's list out everything we know. The highest point of this graph is our absolute maximum. From the graph, do we see our absolute minimum? Way down here, absolute minimum. But then I have another question at the absolute minimum. Can we find the slope at that absolute minimum? What was it, this sharp turn called? Cusp. Just kind of know that that does happen. And then we have our point of inflection happens when I have a change in concavity. So we have point of inflection is right here, POI. My pen's kind of dying. Goodness. So then we can go ahead and list out our part A. So do we all have this? All right. On part A, it says find the x-coordinate of the absolute maximum. And then it says and the absolute minimum. So let's write out absolute maximum at some number and absolute minimum. And it says the x-coordinate. What is the x-coordinate of the absolute maximum from the graph?
0.
Is that the x-coordinate?
Yeah.
Yep. Is that 0? And what is the x-coordinate of the absolute minimum? 2. And if I even wanted a y coordinate, could we do that no problem?
Yes.
Okay, let's go ahead and write the order pair just because. The max is at 0, comma what?
1.
0, comma 1.
And then 2.
And then we have 2, comma how many?
-1.
-1.